For this video, we're going to be discussing deductive reasoning. So what is deductive reasoning? Deductive reasoning is just a method of thinking in which we use rules and evidence to make conclusions. Deductive reasoning is a key part of mathematical thinking, and it's something that we're going to be using later on in geometry when we do proofs. So what we want to be able to do with deductive reasoning is we want to be able to look at an argument and decide whether or not it is true based on some rules and evidence we're given. We also want to be able to use deductive reasoning to come up with our own arguments. So we're going to be discussing three rules, or laws as we call them, that pertain to geometry or pertain to logic. So one of them is the law of contrapositive. And what the law of contrapositive says, that given a statement, both the statement and its contrapositive are either true or false. So either they're both true or they're both false. And remember, if I've got a statement that looks like P implies Q, its contrapositive is not Q implies not P. And as we discussed in an earlier video, these are what we call logically equivalent statements. All right? And they're logically equivalent because they have the same truth value. Either they're both true or they're both false. I can't have one be true and the other be false. It's basically saying that these two are the same way of saying the same thing. So if I look at this example, it says, if you study, then you will pass the test. Well, you studying, that is our hypothesis P. Passing the test, that's our conclusion Q. So this is a way of saying P implies Q. If I look here, it says you did not pass the test. Well, that's not Q. So based on the law of contrapositive, we can say, well, therefore, you did not study, not P. Not Q implies not P. That is the contrapositive. So we're saying that by the law of contrapositive, if P implies Q, then not Q implies not P. They have to either both be true or both be false. Our next law is the law of detachment. And it says, given the statement, if P then Q, so if P then Q, then if P is true, Q also has to be true. All right? This is basically just saying that if I know that P makes Q, or P implies Q, and I know that P is true, then that means that Q must also be true. This seems like a pretty common sense one. So here's an example showing that. It says, if an angle is less than 90 degrees, so there's our P, then the angle is acute. There's our Q. All right? It says B is 87 degrees, so I've got P implies Q. Angle B is 87 degrees. Well, that's less than 90, so I'm being told P. Therefore, B is acute, therefore Q. All right, the law of detachment just says that I couldn't say, well, B is 87 degrees, so therefore it is not acute. No, that doesn't work. If P implies Q and P is true, then Q must also be true. That's the law of detachment. And our third law is the law of syllogism. All right, the law of syllogism is very similar if we remember back to the transitive property. If you remember the transitive property, it said if A equals B and B equals C, then A equals C. All right? It's just, this was the transitive property. Well, the law of syllogism is pretty similar. It says, given the statements if P then Q and if Q then R, then the statement if P then R is also true. So we're saying, well, P implies Q, Q implies R, therefore P implies R. Because P leads to Q, Q leads to R, so P leads to R. All right, it's very similar to the transitive property. So if I look here, it says if you're sick, you miss school. That's saying P implies Q. Being sick is P, and missing school, that's Q. My next statement says you miss school, Well, that's Q again. Then you will fail the test. There's R, so that's Q implies R. That's supposed to be an arrow. And then it says, therefore, if you're sick, that's our P, then you will fail the test. That's our R. Okay, so it's very similar to the transitive property. If P implies Q and Q implies R, then P implies R. So we can use this to decide, we can use these laws to decide if certain arguments are valid. So example 1 here says, is the following argument valid? Justify your answer using the laws of deductive reasoning. If it's not valid, provide a counterexample. So if we're going to say something's not true, we have to say why. So let's take a look here. It says, if the measure of two angles adds to 180 degrees, then the two angles are supplementary. Angles A and B are not supplementary, therefore their measures do not add to 180 degrees. Let's think about this. If I say the measures add to 180 degrees, call that P, and the angles are supplementary, call that Q. Then I've got P implies Q up here in this first sentence. My next statement, A and B are not supplementary, that's not Q. And then down here, therefore, their measures are not 180, that's not P. So I'm saying P implies Q, not Q, therefore not P. Well, we're saying not Q implies not P. Well, that's just the contrapositive of my original statement. Well, we know by the law of contrapositive that if this is true, then this must be true. So I would say that this is a valid argument because this is just an example of the law of contrapositive. So hopefully you see how I'm using deductive reasoning and logic to make sure these are true. All right, let's take a look at another example. Okay, it says, is the argument valid? Justify your answer using laws of deductive reasoning. If it's not valid, we have to provide a counterexample, it says. So it says, if you do your homework, then you get a good grade. Okay, so do your homework. That's P. Get a good grade. That's Q. If you get a good grade, well, there's get a good grade again. That's Q. I've got P implies Q up top. Then you pass the class. Well, this is a new statement, pass the class. Let's call that R. So I've got P implies Q, Q implies R. Well, let's think about that. Then we're talking about, this looks a lot like the law of syllogism to me. Let's go to our next statement. Therefore, if you did not pass the test, then you did not do your homework. Well, this is interesting. I've got not R, did not pass the class, implies did not do your homework. Well, that's not P. So is this true? Well, this looks like a contrapositive here, right? We're saying we know P implies Q, Q implies R, and if I use the law of contrapositive, then that means P implies R. I'm sorry, if I use the law of syllogism, it says P implies R. Well, we know this is true then. We know P implies R, and now I have not R implies not P. Well, this statement, I know that one's true. And this is the contrapositive, and by the law of contrapositive, these have to both be true or both be false. So, well, if my P implies R is true, then not P implies, or not R implies not P, that must also be true. Oh, I'm sorry. This is wrong. Okay? I would say that this is a valid argument, and it is valid. Okay? It is valid because of the law of contrapositive and the law of syllogism. Both of them, if I can remember how to spell syllogism, both of them together make this argument true, which is interesting, but it is a true statement. It does work. All right, let's take a look at another example. Okay, So I've got P implies Q, not Q, therefore not P. Well, this should be pretty cut and dry. This is just the law of contrapositive, so this is a valid argument. All right, let's take a look at this one. Same question. Is this a valid argument based on what we see? It says the measure of an angle is less than 90 degrees, then the angle is not obtuse. So measure of an angle is less than 90 degrees. That's our P. Angle is not obtuse. That's our Q. So this first statement is P implies Q. Here we have the measure of angle A is not less than 90 degrees. That's not P. Therefore, angle A is obtuse. Well, then I've got not Q. P implies Q. Not P. Therefore, not Q. Well, let's think back when we talked about our conditional statements. We discussed, this is the inverse, and we discussed that sometimes the original statement can be true, but the inverse isn't necessarily true. Can we think of an angle that is not less than 90 degrees, but is also not obtuse? Well, of course we can. What if A could measure exactly 90 degrees and be a right angle? This argument does not meet any of our laws. Okay, the law of detachment doesn't apply, the law of syllogism doesn't apply, the law of contrapositive doesn't apply, and we can come up with a counterexample. If we can come up with even one counterexample, then the argument is not valid, and we can. This could be a right angle. So this is not a valid argument. All right, this is a long one, but let's see if we can do this one. It says if a polygon has three sides, okay, let's call that P. Okay, I see if then, so P implies it is a triangle. There's our R. If all three sides of a triangle are congruent, then it is an equilateral triangle. Well, that's, well, I'm sorry, this should be Q. Three sides of a triangle are congruent. Well, that's not P or Q. Let's call that R. Then it is an equilateral triangle. Well, that's a new statement too, so that's S. So I've got R implies S. Triangle ABC is not equilateral. Well, that's not S. Therefore, it does not have three sides. Well, that's not P. Well, do I have anything saying that I have P implies Q and R implies S, but I have nothing saying like Q implies R, or P implies R? I don't know. This looks like a mess to me. I would say that this is not valid. Oh, I don't have anything here. I would say this is not valid. And the reason it's not valid is that there's no real connections here. There's no real connections here. And just because a triangle is not equilateral doesn't mean it doesn't have three sides. Here we go. There's my counterexample. Well, that's a bad one. There's my counterexample. I drew a triangle. It's not equilateral. It has three sides. All right, so see how we do this. If an argument's not valid, we have to come up with some sort of counterexample. All right, here's our final example. We want to use deductive reasoning to fill in the blank here. So I'm given that A implies B, B implies C, C implies not D, therefore D implies what? Well, how do we go about this? What does D imply? Well, D is the opposite of not D. So I do know, using the contrapositive, that D implies not C, right? If C implies not D, then if I negate this, I get D, so I negate C, I get not C. So this is the contrapositive of this statement. And then I know not C, well, not C is going to imply not B, because B implies C, so the contrapositive of this is not C implies not B. And then I know not B is also going to imply not A, also by contrapositive. Okay, so I've used the laws of contrapositive here. Basically just worked backwards. D implies not C implies not B implies not A. So then I can use the law of syllogism, and if I just work my way, well, this one goes here, to here, to here. Well, what can I say? I can say that not B implies, or I can say that D implies not A. And that's my answer. So you can see all I used was the law of contrapositive, and I should have a V and an E, and the law of syllogism to be able to answer this question. All right, that was our final example. So your try it problem for tonight is this. Determine if this argument is valid, justifies your answer using deductive reasoning or a counterexample. So if this is false, you need to use a counterexample. So here's your argument. If two angles share the same sides and vertex, then they are vertical. If two angles are vertical, then they are congruent. A and B are not vertical, therefore angles A and B are not congruent. So this is your try it problem for tonight.